on computational pathology. It all starts with this, which most of you are familiar with, but backing up a little, this is how it all starts. You start with whole slide imaging. The technique of whole slide imaging is very straightforward. It's you take a glass microscopy slide with a section piece on, you put it in a scanner of a vendor, and you get an image out of it. You get a very large image out of it, 100,000 by 50,000 pixels or larger, and that contains a lot of pixel information, and that information you can start mining, and that's why this. That's why we're here at this workshop. Where does this happen? I was talking to some people last night already, and some of the feedback that I got initially is, yeah, I feel really lonely doing what I do at my institute. I'm the only person that seems to care about this. I was so happy to find out about your workshop, actually, because I thought I was alone in the world. So at least when it comes to scanners, there's quite a lot of places in Europe that have scanners already. This is just a survey that we do from European sites, from different vendors. So the potential is definitely there. And to me, an eye-opening experience was definitely 2012, when I was at the DPA Pathology Visions meeting in Baltimore. It was a very memorable meeting, if for no other reason that it took place during Hurricane Sandy, which wiped out a significant part of the North Atlantic infrastructure at the time. But the other very impressive thing that happened to me, and more impressive actually, was the keynote speech by Dr. John Tomatevsky of Buffalo, New York. He was talking, the title of his talk is here. It was called Data Fusion in 21st Century Diagnostics. And to me, my background is bioinformatics originally. I was new into the whole digital pathology scene, and it was like, wow, this is cool. I can actually use the tools that I've been trained to use and apply them to here. Let's just go ahead and do that. And here's just one example of what you could do. I have to attribute this to a group in San Diego. This is not my own work. But you take a pancreas slide, and the first thing you do is you identify where the tissue is. Next step is you identify where the islets of Langerhans are in the pancreas tissue. And then you do quantification of which types of cells there are, which ones are still producing insulin, which ones are the alpha, which ones are the beta cells, etc., etc. So I saw all these techniques combined, and then a few years later, after Baltimore, after I had my aha experience, I realized that, well, there's really still a problem. And what's that problem? Well, you have the microscopy community, the pathologists on one end, and this microscope is actually the result of 400 years of continuous research and ergonomic concerns, etc., etc. So they look at these talks by Dr. Tomasevsky sometimes, and you see everybody nod in the audience, and yeah, this is the future. And then when you ask them in practice, they sometimes answer you, yeah, but maybe 20 years from now this will become doable. And then I go back to my home community, so to speak. I go back to a bioinformatics conference, and I talk to people there, and they look at me like, you're doing what now? You're involved with pathology? Are you crazy? Pathology, does that even happen anymore? You just throw everything in a sequencer and you get the answers out, right? And so there's a huge divide or a difference in expectations, at least. So that's why we're organizing this workshop, to bring both communities together. Looking at the list, I think we have a very good mix of people from the different sides, and we hope to make things happen. And with that, I'm very proud. I'd like to thank our sponsors too, of course, without whom this wouldn't be possible. And with that, I'm very proud to announce the first keynote speaker, Dr. Jeroen van der Laak from BMC Radboud.